Hello and welcome back. In this video, we're going to cover part 3 of the different science concepts that might be tested on the ACT science section. Just like I said before, in case you're happening to come to this one first, the ACT science section, despite the name, barely tests your scientific knowledge of any scientific concepts. It's almost entirely going to be your ability to read graphs and tables. So if you haven't already seen the ACT science intro, graph, and question type videos, go watch those. Those are far more important than this one. They're going to cover the vast majority of what you're going to be tested on. Also, if you haven't seen part 1 and part 2, go watch those because there are a few questions that they're going to ask about science concepts, or there are a few common passage types covering different things that are a little less well known, and it's helpful to have some understanding of a few key things. Those most common ones are covered in part 1 and part 2. Part 3 here, we're going to cover a few of the things where in all the tests I've taken, which are a lot, these are a few concepts that I've seen maybe a couple times. So very rarely, but more than once. So I did want to put a video in here just so there is a chance you're going to run into them, and I want to at least introduce you to them so you can know. But in all of your ACT studying, these are probably the least important. Make this your last thing just to maybe push up these last couple points if you're trying to get really high up and you have the time. Otherwise, really don't worry about these. If I start seeing something pop up again, I might make a part 4 if there's something new that pops up every now and then, but for now, this will be the last video. And as always, if you find this helpful, you can help me out by leaving a like and subscribing. So let's get started. First up, friction and drag. You might have heard of friction before. A lot of people haven't heard of drag force before. They're actually the same thing. It's just going to be a matter of what they're going through. So what are these? Friction and drag are forces that oppose motion. That's what are going to slow things down or make things stop eventually. The most important thing you need to know is that the direction they point is always going to be the opposite direction of whichever way the object is moving. That's really the only thing that you need to know of these two things. You're wondering what the difference is between friction and drag, if you've got a solid going across a solid like a car on the road or a ball on a table or the floor, that's friction. Whereas if you have something going through a liquid or a gas, such as something falling in water or throwing a ball in the air, that's going to be drag. But they're the same thing, it's just a matter of what they're going through. So let's look at an example of a ball sinking in water and what you might actually see on the ACT. So here's the picture of the ball, and just as a reminder, since the ball is sinking in water, it's moving downward. So you might have to pick a graph saying which way the drag force is going, or they might just ask you to pick the direction, up, down, left, right. Well, if the ball is going down, friction and drag always go in the opposite direction of motion, so drag will point up. Now you will have one other force in this example, and that's going to be gravity. That's always going to be there, and it's always going to go down. And just so you know, that's going to be more than the drag force because that's why it's still moving down at all. This is just going to slow it. So this would be the answer on your diagram. Gravity going down, drag going up. If they ask what direction is the drag force, it's up. That's all you have to know for these two. Not a lot, just know which direction. Next up, velocity and acceleration. Again, not something you see a ton of, but just know what they are, and I'll explain a bit about acceleration. So velocity or speed, that's a measure of how quickly something's moving or how quickly the position is changing. You don't need to know the difference between velocity and speed for the ACT. There's a small difference for physics, just in that velocity can be positive or negative to indicate direction, whereas speed is basically the absolute value. But again, you don't need to know that for the ACT, but in case you were wondering, there you go. All you have to know is it's a measure of how quickly is something moving. Whereas acceleration is a measure of how quickly that velocity or speed is changing. So if we think of something like you're in a car, if you want to speed up, you hit the accelerator because that's going to increase your acceleration or cause you to accelerate. That's where the name comes from. So that doesn't necessarily make you go. That is just what makes your speed change. So that is going to, by making your speed change, it is going to make you accelerate. So in that case, if you're not hitting your accelerator, but you're holding a constant speed, let's say you have cruise control on, then your acceleration is 0. That doesn't mean you're not moving. Let's say you're at 60 miles per hour on the interstate, you put on cruise control and you just stay at a constant 60 miles per hour. You're going to have a speed of 60, but your acceleration is still 0 because it's not changing. Whereas if you need to speed up to pass somebody, you're going to have a positive acceleration because your speed is going to be increasing or becoming more positive. Whereas if you have to hit the brake, or if you turn off cruise control and just let go of the accelerator, friction's going to slow you down, and your acceleration is going to be negative during that time because your velocity is going to become more negative or closer to negative, or it's going to get lower, meaning that you're slowing down most of the time. And that's all you have to know between these two. It's just mainly understanding what acceleration is, and that 0 acceleration doesn't mean you're not moving. It can also mean you're not moving because at that point your speed's 0 and not changing. It really just means that the speed is not changing. It's constant. Next up, we have kinetic and potential energy, terms that almost no one has run into because you see this in physics. The good news is you don't have to know much at all about these, but let's cover it since I have seen it a couple times. Kinetic energy is the energy from being in motion. So if you're asked which one has more kinetic energy, the thing that's moving faster gives you more kinetic energy. That's all you got to know. In case you run into it, the thing with higher mass will also have more kinetic energy, but the speed is more important. I've never seen them test the mass part, but just in case. Potential energy, on the other hand, is the energy that comes from being high up. So the higher you are, the more potential energy you have. If you're wondering how does that count as energy, well, it can be converted into kinetic energy if you were to allow it to fall. So let's say you had a ball and you're just holding it up in the air and just holding it there. There's no kinetic energy because it's not moving, but if you were to let it go, it would then start falling and speed up, and it would get converted into kinetic energy. So it has the potential to turn into kinetic energy, hence the name. The higher it is, the more it can fall and the faster it can become, so therefore it would have more potential energy. So in other words, object higher up, it can fall further, and therefore have more time to speed up while it's falling to a higher kinetic energy. And that's why the higher it is, the more potential energy it has. That's the main thing you need to know, is they might give you a few examples of different objects at different points and ask which one has more potential energy. And it's going to be the one that's higher up. Or they might ask which one has more kinetic energy. It's wherever it's moving faster. The most common example you're going to run into is with a roller coaster. So let's run through it. Here's our roller coaster. While you're sitting at the top, not moving, there's going to be no kinetic energy because you're just sitting there waiting to drop. But you will have really high potential energy because you're very high up. But let's say you then hit the drop and you're halfway down. At that point, you are moving, so you do have kinetic energy. You're not all the way down, you still have some height, so you still have potential energy, just less than you had up here, because some of it's been converted into kinetic energy at this point. So at this point, you have both potential and kinetic energy. And once you get to the bottom, you're not going to have any potential energy because you're at the bottom, no height, and instead, all of it will have been converted into kinetic energy. So here you're going to have the most kinetic energy because all of that potential energy has been converted to kinetic. And that's all you got to know about kinetic and potential energy. Again, if they just have a question about at what point on the roller coaster do they have the most potential energy, it's up top. Where do they have the most kinetic energy? Right at the bottom. That's it. Okay, last slide, the terms aerobic and anaerobic. They'll often actually define that for you, but I have seen occasionally they don't, and they actually test to see if you know. Well, usually that's referring to types of bacteria, but it can mean other things. The main thing is that aerobic means it requires oxygen, and anaerobic means it does not require oxygen. That's it. And that'll conclude this video. Again, I know this was moving kind of quickly, a bunch of random things, but again, they're not tested frequently. I just have seen them a couple times, so I wanted to make sure I still introduce you to them. That way you're not caught off guard if you do run into it. So with that, again, if you found it helpful, leave a like, subscribe to help me out, and good luck on your studying.